Welcome to Study Loop.
Problem 726, we have a roofer that climbs up a 7-meter ladder. So I already wrote down what direction of gravity is. So we have him climb up 7 meters. Then he walks 12 meters on the roof. So this roof is flat and horizontal. So we can write he's going that way, 12 meters. Climbs down another vertical 7-meter ladder. Okay, so he goes down 7 meters. Then he finally walks on the ground back to his starting point. So that's another 12 meters. And we're asked various questions. How much work is done on him by gravity as he climbs up? Okay, and then B is as he climbs down, so we might do them simultaneously. So, but for A, we can just write down what our relationship for work and force and path distances. So we have work is equal to the integral of force dot product of the path length. Okay, so here we have force is down and the path length is going up as he climbs to the top of a roof. So we can just write down what the force is. Force is just going to be the gravity acting on him. So that's going to be his mass, so 75 kilograms times 9.81. Okay, then that's going to be multiplied by the path length, so that's 7. And that's going to be the dot product between those two. Those are in equal opposite directions. So that's going to be times a -1. Okay, so this is going to be, let's see, 375G. I'm just going to leave it like that for now for clarity. Okay, then for part B, as he climbs down, the only difference between this one and that one is we have a different dot product. So the vectors are in the same direction. So that's going to be a positive value instead of a -1 here. We're going to get a positive 1. So we're going to get that to be 375 G for the work there. And that's going to be in joules after the units work out. And then C, as he walks on the roof and on the ground. So because the vectors between gravity and the horizontal path distances there are perpendicular to each other, that dot product is going to be 0. So for D, so for C, that's going to be work equal to 0. And then for D, was total work done on him by gravity during this round trip? So we just need to sum up all the work done by gravity on trips. So that's going to be -375 G plus 375 G joules plus 0 plus 0. That's going to be a sum of work is equal to 0. Okay, and on the basis of this, since they went on the basis of the answer part D, would you say gravity is conservative or non-conservative force? A way to determine whether a force is conservative or non-conservative if it takes a path back to its starting point if the work is 0. And because that happened here, we return to our starting point and the work is 0, we can say that gravity is indeed a conservative force.